You've heard of T-Rex. You've heard of Brachiosaurus. But what if the biggest dinosaur outside the sauropod family wasn't a fearsome predator, but a gentle plant-eating giant you've probably never even heard of? This is the incredible untold story of Shantungosaurus, a duck-billed dinosaur so massive it outweighed even the king of the dinosaurs and may have been the largest bipedal animal to ever walk the earth. When we picture the most colossal animals ever to have walked the earth, our minds instinctively turn to sauropods, those long-necked behemoths that dominated the Mesozoic era. Among them, the titanosaurs stood as the ultimate representatives of scale and power. Towering above their contemporaries, they stretched across all 7 continents, achieving sizes never before witnessed in terrestrial life. Some of these giants weighed over 176,000 pounds and extended longer than 100 feet, roughly the length of 7 African bush elephants lined up trunk to tail. In every sense of the word, they redefined what it meant to be gigantic. Their overwhelming presence often leaves little room for other giants to be remembered. But once we set our sights beyond the sauropods, the question arises: which dinosaur was the largest among those that weren't sauropods? The natural assumption might be the massive theropods, the meat-eating titans like Tyrannosaurus rex, renowned for their size and bite force. Indeed, some of these predators approached impressive dimensions, with T-Rex tipping the scales at over 22,000 pounds, yet even they don't hold the crown. The true answer lies far from the well-known fossil beds of North America. Instead, it comes from the rich sedimentary plains of late Cretaceous China. Here, scientists uncovered a dinosaur that, despite its size, remained in the shadows of fame. Its name? Shantungosaurus. Discovered in 1973 in the Wangxi group of China's Shandong Peninsula, Shantungosaurus was first identified from a collection of 5 scattered and incomplete skeletons. While fragmentary, the size of the bones was enough to stun the paleontologists who found them. The sheer scale suggested a creature larger than any hadrosaur previously known, potentially rivaling even the smaller sauropods. Initially, the assumption was these bones belonged to a sauropod, but closer examination revealed something far more unusual. The skeleton bore the hallmarks of a hadrosaur, a duck-billed herbivorous dinosaur, closely resembling the North American Edmontosaurus. Over time, researchers recognized that Shantungosaurus and Edmontosaurus belonged to the same evolutionary lineage, the Edmontosaurini. They shared uncommon anatomical traits, including distinctive skeletal structures and sophisticated dental batteries, which was particularly fascinating given the vast distance separating their fossil discoveries. Yet what was most remarkable wasn't their similarity, but their difference in scale. Edmontosaurus, though one of the largest known hadrosaurs, was dwarfed by its Asian cousin. Even the smallest known specimen of Shantungosaurus, likely a juvenile, had a femur as large as that of a fully grown elephant. The holotype, a nearly complete reference skeleton, measured 48 feet in length and weighed over 26,000 pounds. That's more than 7 times the weight of an average car. But Shantungosaurus didn't stop there. Estimates suggest that the largest individuals could have stretched up to 56 feet and weighed between 35,000 and 40,000 pounds. Some researchers even propose that under more generous calculations, the weight may have reached 42,000 to 48,000 pounds, though such figures are still debated. Regardless, even conservative estimates place this hadrosaur well above any known theropod, including Spinosaurus and T-Rex in both length and mass. More importantly, Shantungosaurus also surpassed every other known ornithischian, the major group of herbivorous dinosaurs that includes icons like Triceratops and Stegosaurus. In fact, the largest known femur from Shantungosaurus rivals those of mid-sized sauropods. And while the body proportions of hadrosaurs and sauropods differ significantly, making it unlikely that Shantungosaurus ever approached 200,000 pounds, it remains an undisputed giant among non-sauropod dinosaurs. To better visualize its enormity, consider this. Shantungosaurus was over 3 times the size of Stegosaurus, more than twice as heavy as the armored Ankylosaurus, and approximately 40% larger than the largest Triceratops ever discovered. In human terms, its mass equaled that of 260 average people. Because it may have been able to walk at least partially on its hind legs, it's often recognized as the largest bipedal animal to have ever existed. When compared to land mammals, only 2 contenders approach its size: the giant elephant, Paleoloxodon pneumaticus, and the hornless rhinoceros, Paraceratherium. Though each has been credited with exceptional size estimates, Shantungosaurus likely outclassed them both in average weight and length, making it a strong candidate for the title of the largest land animal outside the sauropod group. What makes this even more astonishing is that these weren't just rare outliers. With over 50, possibly up to 100 Shantungosaurus specimens on Earth, scientists believe that large body size was typical for this species. Most individuals likely weighed well over 22,000 pounds, suggesting that extreme size wasn't an evolutionary accident, but a consistent trait, likely tied to both environmental pressures and feeding strategies. So, why did Shantungosaurus grow so large? The answer remains elusive. Theory suggests that its size may have served as protection from predators or allowed it to reach higher vegetation. Larger animals often benefit from increased digestive efficiency and lower per-pound metabolic needs, making them more capable of extracting energy from poor-quality plant matter. In its ecosystem, the only other giant was the titanosaur Zhuqing titan, which may have been slightly smaller. Usually in this environment, the largest dinosaur was not a sauropod but a hadrosaur, making adult Shantungosaurus essentially immune to predation. Its main predator, Zhuqing tyrannus, was a large tyrannosaur similar in form and role to T-Rex. However, its estimated adult weight was only around 11,000 pounds, about a third of that of Shantungosaurus. While juveniles may have been vulnerable, adult hadrosaurs were likely safe from attack due to both their size and the fact that they likely traveled in large, coordinated groups. Yet size wasn't its only defense. If Shantungosaurus charged, it could deliver a devastating impact, more powerful than 1,000 heavyweight boxer punches. Some researchers even suggest that being in front of this dinosaur was safer than standing to the side or behind it. Why? Because hadrosaurs may have been capable of delivering deadly kicks with their powerful hind limbs, which in the case of Shantungosaurus were massive and muscled. A single backward strike could have easily incapacitated even the most determined attacker. Its tail was equally formidable, longer than 2 cars, thicker than most sauropod tails, and reinforced with heavily ossified tendons. While rigid, it could likely swing from side to side, functioning much like a club. If used with force, it could have caused significant injury to any predator that dared get too close. It didn't travel alone. Shantungosaurus moved in herds, making any coordinated attack by predators even more difficult. Fossil evidence also shows that it had large nasal openings, possibly covered by inflatable skin flaps in life. These may have been used for vocalizations, calls to warn others of danger, establish dominance within the herd, or even for mating displays. Its bones, too, were exceptionally robust, suggesting a body built not just for size, but for endurance and strength. In the end, Shantungosaurus was an herbivore, a peaceful browser of the ancient plains. Yet its mouth was a marvel of evolutionary engineering. With over 1,500 teeth arranged in vertical columns, its dental system continuously replaced itself. These teeth were complex by dinosaur standards, ideal for grinding down fibrous plant material. Its wide beak allowed it to shear leaves and stems efficiently, and may have served for nipping as well. With such bulk and feeding power, a single herd of Shantungosaurus could reshape an entire landscape. Even modern elephant herds can drastically alter vegetation density. Imagine what 50 of these dinosaurs, each weighing over 22,000 pounds, could do. Their constant movement and feeding likely shaped plant distribution, soil patterns, and even influenced the behavior and distribution of other animals. It's very likely they acted as a keystone species, influencing everything around them simply by existing in large numbers. Shantungosaurus lived in what is now the Wangxi group, which during the Cretaceous was a lush floodplain with a warm, humid climate and abundant plant life. Cycads, ginkgos, conifers, and ferns. It shared this environment with a range of other dinosaurs, including Triceratops, Zhuqing-ceratops, Ischioceratops, Zhuqing titan, Anomalipes, Tannius, Peninsula, Micropachycephalosaurus, and even an undescribed Ankylosaur. This was a true dinosaur hotspot, one of the most fossil-rich formations ever discovered. Though other animals lived here too, fish, turtles, and a crocodilian, the ecosystem was clearly dominated by dinosaurs. Interestingly, despite existing for over 10 million years, Shantungosaurus had a relatively limited geographic range. Unlike many hadrosaurs, it wasn't widespread. Its immense size may have limited its habitat options, and the presence of other large herbivores like titanosaurs may have restricted its expansion into surrounding areas. But eventually, Shantungosaurus vanished. How does an animal of this size go extinct? Theories vary. One possibility is that environmental change reduced the resources needed to sustain such massive creatures. As climate shifted or vegetation changed, the energy demands of an animal this large may have simply become unsustainable. Another possibility is that a local extinction event, perhaps tied to volcanic activity in this region, disrupted the delicate ecological balance. Fossil layers containing volcanic ash and lava flows suggest that parts of Shantungosaurus' habitat were affected by intense geological disturbances. Lastly, some scientists suggest that Shantungosaurus didn't die out abruptly, but instead evolved into a smaller related hadrosaur. After all, hadrosaurs remained common in Asia until the very end of the Cretaceous, although none ever reached the same size again. Shantungosaurus was the pinnacle of its lineage, the last great giant of its kind, a silent ruler of the ancient floodplains. Thanks for watching Prehistorers Extinct. If you enjoyed this journey through the world of one of Earth's mightiest herbivores, don't forget to like, subscribe, and share. Stay curious, and until next time, remember, extinction is never the end, only the beginning of discovery.